Hello everyone. Let us solve the definition where we read a number from the user and decide whether it is an Armstrong number or not. Now, to decide whether a number is an Armstrong number, you need to take each digit of the number and raise it to the total number of digits in the number. For example, if you have a number like 123, then you will take 1 raised to 3 plus 2 raised to 3. The 3 indicates the number of digits in the number. So if this total is equal to 123, then it is a Armstrong number. Say if you take the number 12, then 1 raised to 2 plus 2 raised to 2. If this is coming to 12, then it is an Armstrong number. So that way is each of the single digit numbers are considered as Armstrong numbers. So let us try and solve this. So first thing, we will need to know how many digits are there. So I'll take a variable n and let me find the length of the string. Okay, now in future I will need the number b because I'm going to reduce the number every time I run my loop. So okay, one thing more, I'm going to take b1 and store the number b in it. If not required at a later stage, we can just remove it. Okay, now, Armstrong numbers are considered to be any number when entered should be an integer number. It cannot have a fractional part. So, as usual, we'll have to have the %int of b. You can take the % of a also. And I'll need to make sure that it is an integer. So, let's say b is equal to c and something is entered. We cannot try and convert empty string into a number. We need something. So the length of the string should be greater than 0. So if this is there, I will go ahead and do the logic. Otherwise, we'll throw an error saying, well, so the first thing is done. Okay, the second thing. Now I will need to find the Armstrong number. So every time I'm going to extract one digit and I'll raise it to n, where n is the number of digits. So let us start with the initial value of Armstrong. Okay, we'll just take arm. Say the initial value is 0. Now, for the total number of digits, which is stored in n, I'm going to run a for loop. So starting I equals 1, I less than equal to n. So as many characters are there in the string or as many digits are there in the string, this is what I'm going to do. So I'm going to extract each of the digit by using the modulo, right? So digit should contain the last digit from the the string, the number. Okay, the next thing, I'm going to reduce b by removing the last digit. So I'll again use in the %int on b after dividing it by 10. So if the number was 123, digit would contain 3 and b should contain 12, because the next time when you're running the loop, we are going to extract 2. So I think this should work. And the last thing, we'll need to have the Armstrong number. So the digit which I'm getting has to be raised to the power of n, where n is the total number of digits in the number or the number of characters. So I'm going to use in the math object and we'll use in the power function. The first parameter is the digit and the second parameter is n. We have a little spacing issue. Okay, so I think the for loop is done here. So once my for loop is over, arm should contain a number which is the Armstrong equivalent of the number. And if that number is equal to the original number, that means, simply put, when I take the digit raised to n for every digit in the number, and if the sum total of it comes to the original number, then the entered number is an Armstrong number. That's the logic. So here I'm just going to print in that it is an Armstrong number. Otherwise, we will just say it is not an Armstrong. Right? Let us see if this logic works. So I'm going to enter, say, the digit 5. Obviously, uh, oh, okay. I made a mistake. Here I will need to write in the Armstrong is equal to the original number, not n, right? Because individual digits are Armstrong numbers, right? Okay, so 5 works. What about 12? No. Okay. What about 153 is an Armstrong number, so it says yes. 165 is not an Armstrong number, so it says it is not. 100, so basically 100 is 1 raised to 3 plus 0 raised to 3 plus 0 raised to 3. Will never come to 100. So there are a few numbers which are Armstrong numbers. You can Google them out, and that's the logic for our definition. A little lengthier logic here, but this is the simplest way by which you can find out whether a number is an Armstrong number or not. Now, if you enter a 4-digit number, for example, 1, 2, 3, 4, then it will take 1 raised to 4 plus 2 raised to 4 plus 3 raised to 4 plus 4 raised to 4. If this total is coming to 1234, then it is an Armstrong number. 1, 2, 3, 4 is not an Armstrong number, right? Test this out, and we'll take up a new definition in the next video.